So good morning everyone. My name is Rajnikam. I am a BTech student at the College of Engineering and Technology, Kolhapur. Today I will be presenting on the topic polynomial regression. Now let's start with a simple question. Why do we need polynomial regression? Linear regression works only when data follows a straight line tree. But in many real-world situations, data shows curve instead of straight patterns. Polynomial regression helps us capture these non-linear relationships. This makes our predictions more accurate. And that's why polynomial regression is widely used in economics, biology, and engineering. For example, here I have shown you two graphs. Here is the simple regression, and here is the polynomial regression. The difference here is the simple regression shows the straight line, and in the polynomial regression, we should see a curved line. And predicting population growth or analyzing chemical reactions often needs a curve model rather than a straight one. Now, what exactly polynomial regression means? It is simple and extension of linear regression. Instead of fitting a straight line, it fits a curved line to the data. The general equation looks like y is equal to b0 plus b1 into x plus b2 into x square plus b3 into x cube, such that it goes out to Vn into x raised to n. Now here, the degree of polynomial controls how flexible a curve is. A quadratic equation of degree 2 can capture U-shaped curves, while higher degrees can capture more complex patterns. Now in the example, you have shown the image that the linear regression shows the straight line. In the quadratic, we should see a U-shaped, and in the cubic, we should see a more complex pattern. So in the next part, so we will see how does polynomial regression actually works. Let's break it down into the steps. In the first steps, we chose the degree of the polynomial. Then in second, we transform our input data into the higher powers like x square, x cube, and so on. And now in this third steps, next we apply linear regression but with more transform features. After that, the algorithm finds the best curve by minimizing the error in the four steps. Now in the fifth steps, finally we see this curve to make the predictions. In short, it's like taking the linear regression but adding extra curve power to it. For more clarification, I have given you the diagram to uh, self-study. Now in the diagram, they are we start, then we assign the initial values, then assign the prediction function which we are going to use. So in the next, we are going to see a cost function, and next part there is a convergence of the parameters. And if the model fits, then we stop, and if not fits, then we change the parameter until we get a convergence of the parameters to the right fit of the curve. Now in this next slide, there is a challenges and what are the drawbacks of the polynomial regression. Of course, polynomial regression has some challenges. If we choose a degree that is too high, the model may overfit. It will flow the training data too closely and fail onto the new data. If the degree is too low, the model may underfit. It won't capture the true pattern. It is also sensitive to outliers, meaning a new extreme points can distort the curve. And finally, it may not always generalize well for the unseen data. Now here is the example we see for the degree 1, degree 4 and degree 15. Now here comes the summary. So let's summarize. Polynomial regression is a curved version of the linear regression. Next point, it helps us to capture nonlinear patterns in the data. In the third, it is useful in fields like economics, biology and engineering. But the choice of polynomial regression is very important. Too low leads the underfitting and too high leads to the overfitting. When we applied the polynomial regression carefully, it is powerful technique for better predictions. Thank you so much for your attention.